Hello everyone, welcome back to your favorite and India's most affordable learning platform, Physics Wallah. So in the last session, the thermal properties of matter where we discussed the heat capacity concept, that is specific heat capacity, and the calorimetry concept. So today we are going to continue with the same concepts. So some questions on the calorimetry, and then what is water equivalent, and then what is heat capacity or thermal capacity, which is also called, and the latent heat, and the latent heat plus calorimetry based questions we'll see in today's session. So as usual, I just need your attention for the next 1 hour, guys. Just be with me, avoid all the disturbances around you for the next 1 hour, and at the end of the lecture it's very important to prepare your own short notes. Okay, so my energy might be a bit low today, I am not feeling well, so but the concepts I'll cover completely. Okay, chalo. So first let's see what is thermal capacity. So before going into the today's concept, so first let's see what is thermal capacity or heat capacity. So the thermal capacity, or which is also called the heat capacity. So the thermal capacity or the heat capacity. So see here, so in the last class we have seen what is specific heat capacity, right? So it's the amount of heat required to raise a unit mass of a body by unit degree centigrade is called the thermal specific heat capacity. So here the thermal capacity or the heat capacity, it is denoted with capital C. Specific heat capacity is denoted with small c. So it is defined as, so the amount of heat, it's the amount of heat required to raise the temperature of whole body by 1 degree centigrade by, so 1 degree centigrade is called the heat capacity or the thermal capacity. Clear? Sure. So now, so this heat capacity is denoted as capital C, so which is equals to, so the mass into the whole body mass into, so its specific capacity. Specific capacity means per the heat required to raise the temperature of the unit mass by unit degree centigrade, unit mass of a body by unit degree centigrade. So here in place of unit mass, so I am writing the specific heat capacity. So total mass into the specific heat capacity will give the heat capacity or the thermal capacity. Okay, clear? Understood everyone? Chalo. So what are the units that you can write? So here, so it's going to be generally, so the mass, let's suppose if you take it in kg, and then for C it is going to be joule per kg degree centigrade. So then kg can cancel, so joule per degree centigrade, or joule per Kelvin, or calorie per degree centigrade, or calorie per Kelvin. So anything you can write. Clear? So this is about the heat capacity. Done. So next, so let's go for the water equivalent. So what is water equivalent? See, so the water equivalent of a given body is that mass of water whose heat capacity is equal to heat capacity of the given body. See here, so we have to take the water amount, the mass of the water whose heat capacity of the water is equal to some particular mass, some particular body is there, so that body is heat capacity. So let me tell you clearly. So let's suppose you have a body here whose specific heat capacity is there. Now water equivalent means you have to take some amount of water, you have to take some amount of water. Let's suppose the mass of this water is mw. So this mass of water should have the same specific heat capacity as of this body. You can substitute this body in place of this another body, and that means you can substitute this water in place of this body. So this body is heat capacity and the water heat capacity. So how much water you should take whose heat capacity should be equals to the heat capacity of a given body. That's it. Okay, so that means the heat capacity of water, so the heat capacity of water should be equals to, so the heat capacity of body should be equals to heat capacity of body. So that's it. So here heat capacity of water means, what is the heat capacity formula? Just now I wrote. So let's say CW into mass of W, specific heat of the water into mass of the water is equals to, so let's say mass of the body into specific heat of the body. So here this MW is in, so how much mass of the water you are taking, so which is which has the same specific heat capacity as of the body. So this mass is in, this mass of the water is called the water equivalent. That's it. This is called the water equivalent. Done everyone? Clear? So simple definition. So note this down everyone. Noted? Chal. So let's go for the simple question. So try to solve this question on your own, guys. So the water equivalent of 400 gram copper calorimeter. So you have to find 400 grams copper water equivalent. Sorry, so my throat is not good. So just try it on your own. I'll just stand aside for 10 seconds. So just try to solve it on your own. See, you can take the water 4 joule per gram degree centigrade, and then for the copper it's going to be 0.42 joule per gram degree centigrade. So now you have to find what is the water equivalent of 400 gram of copper calorimeter. Done. See, C of water equivalent is equals to C of body. That's it. You have to substitute that. C of water equivalent. So try to solve this question on your own first. C of water equivalent, the specific capacity, the heat capacity of the water equivalent is equals to, so the heat capacity of the body. So that's it. So what is the heat capacity of water equivalent? So the C of water into, so the mass of water, which is equals to, so C of the body into the mass of the body. So then substitute the value C of the water. So for the water it is 4.2 into joule per gram degree centigrade we are taking. So mass of the water is nothing but how much water you are taking, that is the water equivalent. So and C of the body, so here copper, so that's why 0.42 into, so mass of the body, what is the mass of the body? 400. So simply, so let's do one thing. So I can write, so 42 by 10 into mass of the water is equals to, here 2 zeros I am multiplying, 42 into 4, right? So 42 gets cancelled. So the mass of the water is equals to 4 into 10, 40. So this 40 grams is nothing but the water equivalent. That means if you take 40 grams of water, so its specific heat capacity will be equals to the specific, not specific heat. So the heat capacity of 40 grams of water will be equals to heat capacity of the 400 grams of copper. That's it. Done? Clear everyone? Understood this part? Chal. So now let's go for the next one. So try to solve this question on your own. So try to solve this question on your own, everyone. First what's the question says? Here calorimetry plus water equivalent. So both the concepts are involved. A vessel contains 110 grams of water. So the heat capacity of vessel is equals to 10 grams of water. So the initial temperature of the vessel is 10 degrees centigrade. If 220 grams of hot water at 70 degrees centigrade is poured into the vessel, the final temperature neglecting radiation loss will be. Okay, see here. So the interesting question. So first there is a vessel. So a vessel contains 110 grams of water. So this is water, 110 grams of water. So the heat capacity of the vessel is equals to 10 grams of water. See here, the heat capacity of water is equals to, so 10 grams of water. So which is nothing but the water equivalent is given. So the water equivalent is 10 grams here. Fine. So the initial temperature of water in the vessel is 10 degrees centigrade. That means initially this water is 10 degree. So the vessel also will have the same 10 degree. Vessel also will have same 10 degrees centigrade. Fine. So now if 220 grams of hot water. So now 220 grams of hot water, which is at 70 degrees centigrade, hot water is poured into the cold water. So then the final temperature. So here what is the hot body and what is the cold body in this particular case? The hot body and the cold body. So substitute the values simply. So here the hot body is a hot water whose mass is 220 grams, right, and which is at 70 degrees centigrade. Yes or no? 70 degrees centigrade. And then the cold body, so which is a water and vessel. So water, whatever the water inside the vessel, so both will have the same temperature 10 degree. So water and vessel are the cold bodies here. So now, so what is the mass? So the mass is 110 grams, right? So and the temperature is 10 degrees centigrade. So now, so according to the principle of calorimetry, there is no loss of energy. There is no loss of heat energy by the radiation. So you can write like, according to the principle of calorimetry, the heat gained by, the heat lost by the hot body is equals to heat lost by hot body is equals to heat gained by the cold body. Heat gained by cold body. Yes. So now I can say that, so this hot water loses some temperature and then comes to some temperature T, and cold water and vessel, so they raise the temperature to T. That's it. So now here I'll write in the next slide. So the heat lost by the hot water. So what is the heat lost by the hot water? So M into mass of the hot water. Let's write mass of the hot water and C of the hot water into delta T. Hot water is losing how much temperature? Final is T and initial is 70. So 70 minus T. 70 minus T. Sorry. 70 minus T. So next, we have, so the cold body. So the cold body and C of the cold body, and its temperature raised to, so from where to where? 10 degrees to T. So the final is T minus 10 I can write. And then here C of the vessel, mass of the vessel into T minus 10. So that's it. So then substitute the values. So what is the mass of the hot water? What is the mass of the hot water? So mass of the hot water is 220. So just follow the values, guys. So 220 into, so what is the specific heat capacity? C of the hot water is nothing but specific heat capacity. So let's take, these are all in given grams. So let's take 4.2, okay, into 70 minus T. So here mass of the cold water. So what's the mass of the cold water initially? 110. So 110 into, so this is 4.2 into T minus 10. So here, so this is a catch you should, this is a point where you should catch the hint. See here MVCV. So shall I write, so the MWCW is equals to MVCV. So because the water equivalent is given in the question, Yes or no? So what is the water equivalent? The MW is given. So CW you can substitute in place of MVCV. I am writing MWCW. Yes or no? Into T minus 10. Because we don't know what is the mass of the vessel. We don't know what is the vessel specific heat capacity. So but we know the water equivalent. So the water equivalent, so we can equate it, right? So then substitute the values simply. So 220 into 4.2. So let's do one thing. So here I'll write so 220 into 4.2 into 70 minus T is equals to, so 110 into 4.2 into T minus 10. So here mass of the water. So what is the mass of the water? Which is nothing but equivalent. So which is 10 grams. So 10 into, so the C of the water, which is 4.2 again, into T minus 10. So all the values are known except T, capital T. So then simply go for the calculation. So here 4.2, 4.2, 4.2 gets cancelled. So then find the final answer. So 220 into 70 minus T is equals to, so T minus 10 I am taking common. So here I will get 1110 plus 10. So which is 120. 110 plus 10 here. Yes. So then 0 0 cancel. So 6 2 6 times 2 11 times. So this comes out to be 770 minus 11T is equals to, so 60 minus 60, right? So then, so this send it to that side and send 11 plus 6, 17T is equals to, so 830. Yes or no? 17T is equals to 830. Yeah. So from here, so T is equals to 830 by 17. So 17 ones are 17, 5s are 17, 4s are and 17 5s are. So approximately 50 is their answer. Yeah, approximately it comes out to be 50 nearly, because so it goes 7 5s are 85. So closely 49 point something that we get, around 49 point something. So which is equals to, approximately equals to 50 degrees centigrade I am taking. So which is option 4 is the correct one, guys. Done. The closest option I am taking. Understood the procedure? So here this part we already learnt in the last class. The hot body, cold body. So the principle of calorimetry we studied it in the last class. But so the water equivalent. So that water equivalent of the heat capacity of vessel. The heat capacity of the vessel. That means C, capital C of vessel is equals to 10 gram of water. 10 gram of water means, so the heat capacity of vessel, what is the heat capacity of vessel? CVMV. CVMV is equals to, so 10 grams of water is nothing but water equivalent, that is MW. That's it, right? So MW, sorry, CW. Done. So that's it. So this point you have to substitute it here. Clear? Chalo. So let's go for the next one. So now what is latent heat? See, so the amount of heat required to change the state of unit mass of body. See here. So let's suppose if you heat any body, for example I am taking so water. So let's suppose water is initially at room temperature. So consider 25 degrees centigrade. Now so we supplied heat. So then water temperature raised to, let's say, some 100 degrees centigrade. So now still you are supplying the heat. Still you are supplying the heat. Okay. So the water temperature is still remaining 100 degrees centigrade, but it is becoming vapor. It is becoming vapor. So after 100 degrees centigrade, still if you supply the heat, so the water is becoming the vapor, vapor. Okay. So here the heat that you supplied from here to here is not used to raise the temperature of the body. It is used to change the state of the body. Here it is used to raise the temperature 25 degrees to 100 degrees centigrade. So the heat that you supplied is being utilized in raising the temperature of the body. But here, so the heat supplied is being used or utilized in changing the state of the body. So here the state change occurs. So from here to here, the change in state, the change in state. So, clear? Done, guys. So this amount of heat, whatever the amount of heat that you supplied, is called the latent heat. Done? Clear? So here actually we have two types of latent heats. So one is a latent heat of vaporization, the other one is a latent heat of fusion or melting. Okay, so the latent heat of vaporization or condensation, anything. So which is LV we can write. So the heat required to not to raise, to change the state of a water from water to vapor. So for example, if you take water here, so which is at 100 degrees centigrade now, so if you supply heat, okay, so that heat is being utilized in converting this water to vapor. So the heat that you supplied in this particular case is called the latent heat of vaporization, so which is denoted with LV. So here I can write, so the Q is equals to the heat that you supplied is equals to, so LV by, so LV by, see what is the heat capacity that we wrote. So the heat capacity C is equals to M into C, right? So here LV by, so how much mass, so whatever the mass of the water is there, so to convert that mass, so we used this one, sorry, LV is equals to Q by M. Yeah, this is correct. Yeah, so I have mistaken, so this is correct one. So done. So then the heat will be equals to M into, so the LV, so the heat absorbed, so the heat will be absorbed, so then the change in state occurs from water to vapor. Done, guys. So Q is equals to M into LV, where LV is a latent heat of vaporization. Done. Chalo. So similarly we have latent heat of fusion. Latent heat of fusion or melting. So which is LF. Okay, so here let's suppose if you take ice, so which is at 0 degrees centigrade, so now you supplied the heat, let's suppose you supplied the heat, so then its heat, its ice will convert to water, ice will convert to water at the same temperature 0 degrees centigrade. Okay, so whatever the heat that you used, that you supplied, is not being utilized in changing, increasing the temperature of the body, it is being utilized in changing the state of the body. So the heat that you used is called the latent heat of fusion, so which is, so Q is equals to here M into LF. So M into LF. So our Q is equals to M into LV is a latent heat of vaporization, and latent heat of fusion is M into LF. So where if the temperature is constant and heat that you supplied is utilized in the change in state, so that heat is called the latent heat. So if water is being converted to vapor, so then it's a latent heat of vaporization. So if ice is converted to water, so then it's a latent heat of fusion or latent heat of melting. It is latent heat of vaporization or latent heat of condensation. Done? Clear? So this part is clear, latent heat concept. So very, very important. Now we are going to combine, so the latent heat and the heat absorbed by the body to raise its temperature. So both we are going to combine. So just note this point. Done? Chalo. So you can remember the values also. So for the water, it is 2260. Okay, so joule per kg, joule per kg. So R 530, I guess. So 530 calorie per kg. Clear? So note that point. Done? Everyone? Clear? Somewhere around 530 or 540 will be there. So you can take approximate value. Sorry, per gram. This is calorie per gram. So 530, or you can take 540 also. Approximately something around 530, 540 it will be. Done? So this is for the water. And for ice also, so you can write the latent heat of fusion. So the LF for ice, so which is 336. So joule per gram or 80 calorie per gram. 80 calorie per gram. So done. So these values you guys should remember. Done? Clear? So now, so one thing, so till now what you learned, so if it is a temperature change, so then the heat absorbed or heat released, the heat absorbed or the heat released by the body is equals to mc delta T. So this Q is a heat absorbed or released. Heat absorbed or released. Done? Yes. So next. So if you supplied the heat but there is no temperature change, but only the state change occurs. The state change. So then the heat released or absorbed will be equals to M into L. So this is a heat absorbed or released. Heat absorbed or released. Clear guys? Understood a concept? Done? So now based on this we have to solve the questions. So you understood what is latent heat and how do we write the heat absorbed, the latent heat absorbed or released in the case of fusion and in the case of vaporization. So now, so the latent, so we don't need another slide for this. So later, so we have actually the slides, but I am deleting this, so not required because I already wrote here. So just, so go for the question. So what's the question says? Heat required to convert 1 gram of ice at 0 degrees centigrade into steam at 100 degrees centigrade. First draw the flow chart, so then go for the procedure. So what is the heat required to convert 1 gram of ice? So here is the ice. So this is a 1 gram of ice. So which is at 0 degrees centigrade. So it has to convert into steam at 100 degrees centigrade. So the final we required, so 100 degrees centigrade, but steam which is at 100 degrees centigrade. That's it. Done? Chal. So now see, first ice which is at 0 degrees centigrade, so upon supplying the heat it will become, so water at 0 degrees centigrade. Yes. So and the heat that you supplied is the latent heat of fusion. The latent heat of fusion. Yes or no? So the heat that you supplied here, the latent heat of fusion. So Q is equals to M into LF. Done? Chalo. So then, so the water from 0 degrees centigrade to, so the water raises its temperature to 100 degrees centigrade. So this 100 degrees centigrade is again water. So here the temperature that you supplied is, the heat that you supplied is MC delta T. Done? So next, so from here water at 100 degrees centigrade, so it will become vapor at 100 degrees centigrade or steam at 100 degrees centigrade. So here the heat that you supplied is M into, so LF, so LC, LV, vaporization, right? LV. So now the total heat, so the total heat required is equals to, so substitute the values. So we have ice to water 0 degrees 0 degrees, so which is latent heat of fusion, so MLF plus next, so 0 to 100 degrees centigrade, so MC delta T plus, so here M into LV, M into LV. So right, so here LF is of the ice, latent heat of fusion is of the ice, guys. And then so here latent heat of vaporization is of water. So then simply substitute the values and get the answer. Substitute the values, that's it. Just substituting the values. Latent heat of fusion of ice, take it in calories. So I'll write here 80 calorie per gram. Can you guys do this as a homework? So what here 1 gram ice, so here 80 calorie per gram. So and here mass of the water, so how much mass? 1 gram again. So C of the water, you know, so how much in calorie we are taking, so take it as 4.2 calorie per gram. And then so delta T and mass of the water, you know, and LV of the water. So latent heat of vaporization of water, see here, so previously I wrote here, so for the water, so it is in calorie, so consider it as 540 calorie per gram. That's it. Done. Can you guys substitute and get the answer? Done. Clear? Clear. This is C of the water, guys. So what do you take C of the water? 1 calorie per gram you can take. Okay, so take this as a homework. So do the calculations. Take this as a homework and comment your answer. Just everything I wrote, you have to substitute the values. That's it. Done. So next we have got one more question. So try to solve this question on your own. So a piece of ice of mass 40 grams is added to 200 grams of water at 50 degrees centigrade. So calculate the final temperature of water when all ice has melted. So the specific heat capacity of the water is given 4000 joule per kg Kelvin. So and specific latent heat of fusion is given 336 into 10 to the power 3. Okay, fine. So see here. So piece of ice which is 40 grams. This is a ice. I'll tell the procedure. You have to do the calculations. 40 grams is added to 200 grams of water. So ice is at what temperature? A piece of ice of mass 40 grams is added to, okay, so 200 grams of water. This is water which is at 50 degrees centigrade. Yes. So calculate the final temperature of water when all the ice has melted. So the complete ice has melted. So then what is the final temperature? So here hot body is what? Water is a hot body. Getting? And ice is a cold body. But so the thing that you have to understand is, so before melting in water, so the ice which is converts to water first. Ice will convert to water first, and then so it will mix in the water. Yes or no? Then the temperature will rise. Ice at some temperature is there. So then it will become water at 0 degree centigrade. It become water at 0 degree centigrade. Then so it is ice at 0 degree centigrade initially. So it will become water at 0 degree centigrade. So then its temperature will be raised to some temperature. So room temperature or some other temperature. So then it will come to some temperature T. Then so whereas hot water, so its temperature directly comes to some temperature T. So what are the heats required here? So the heat lost by hot body is equals to, so the heat gained by the cold body. That's it. So you can write the concept now. So just write the formula on your own now. Just write the formula. Here hot body is only water, but in the cold body you have to write latent heat of fusion plus the temperature change. So hot body is only the water, mc delta T. The heat lost by the hot water is only mc delta T. So whereas cold body, first it converts ice to water at 0 degree centigrade. So that is latent heat of fusion. Here whatever the heat that is supplied is the latent heat of fusion. Done. So plus here, so the temperature raised, so from where to where, mc delta T, mc from water to mc delta T. So then substitute the values. So what is the mass of hot water? 200 grams into, so this is kg per Kelvin is given, let me take gram per Kelvin, so 4.2. So what is the temperature change of the hot water? So from 50 degrees to T. So here fall in temperature takes place, here rise in temperature takes place. So this is going to be 50 minus T. Okay, so the terminology might be confusing, but you should proceed, like you should follow the same terminology, or you can use your own terminology, your wish. Okay, in different books it will be different terms they use. Okay, clear? So but the concept is same. Done. So here m, so what is the mass of the ice? So 40 into, so LF, so it is 336. This is given for kg, so that's why I am taking for gram, which is 336. So plus, so here, so this water, so what is the mass of the water again? So same 40 grams of water into, so what is the C? So we can write 4.2. So into what is the change in temperature here? So the change in temperature will be, so T minus 0. So T minus 0 is T. So the only unknown is T here. We got 200 into 4.2 into 50 minus T is equals to 40 into 336 plus, so here 40 into 4.2 into T. So the only unknown is T. So can you guys solve this? So homework, just calculations I am giving it as a homework. Okay, and comment your answer. Understood guys? Clear the procedure, everyone? Sure. So note it down. So just try it on your own. I'll just hold for 1 minute. Chalo. So let's go for the next question. So the question number 5. So what's the question says? Steam at 100 degrees centigrade is passed into 20 grams of water at 10 degrees centigrade. So when water acquires temperature of 80 degrees centigrade, so the mass of water present will be, so here specific heat of the water is given and latent heat of the steam is given. So first try to understand the given question. So steam which is at 100 degrees centigrade is passed into 20 grams of water at 20 degrees centigrade. So first there is steam and water. Done. So water is of mass 20 grams. So which is at temperature 10 degrees centigrade. So steam, we don't know what is the mass of the steam. Let the mass of the steam be X. So which is at 100 degrees centigrade. So the steam is 100 degrees centigrade. So then, so here this will become the hot body and this is a cold body. So now, so when water acquires a temperature of 80 degrees centigrade, so the water acquires a temperature of 80 degrees centigrade. So the final temperature has become 80 degrees centigrade. So the mass of water present will be, we have to find what is the mass of water. So first understand the concept. When you pass the steam over the water which is at 10 degrees centigrade, first steam will convert to water. Steam which is at 100 degrees centigrade, steam which is at 100 degrees centigrade, so will convert to water at 100 degrees centigrade, right? So that water will mix with water with the 10 degrees centigrade. So that concept I can write. This is steam at 100 degrees centigrade, so which will become water at 100 degrees centigrade. Yes. So then this water whose temperature, this water and this water mixes and the final temperature has become 80 degrees centigrade. So here the rise in temperature takes place, here the fall in temperature takes place, but the hot body is not directly the water. First it is steam, then converting it to water, and then it is mixing with the cold water. So the same concept you can apply. So the heat lost by the hot body is equals to, so the heat gained by the cold body. The heat gained by the cold body. So here the cold body is only this water. The cold body is only this water. So which is, I can write M of the cold water into C of the cold water into the delta T. So here hot body, first steam to water. Steam to water. So that is latent heat of vaporization. So mLV first plus mc delta T. Then its temperature falls. So to some 80 degrees centigrade. So that's it. So now you got the idea. So whose mass? Let it be X. So latent heat of vaporization of water. So they already gave it in the question. So the latent heat of vaporization of steam they gave. So which is 540 plus. So the mass of the water. So what's the mass of the water? So the X. Yes or no? So X is the mass of the water and C of the water. So what is the specific heat capacity of the water? So which is 1 into, so delta T. So how much temperature change from 100 to 80? So the temperature change is 20. Done. So which is equals to, what is the mass of the cold water? So mass of the cold water is 20 grams into, so this is C is again 1 into, what is delta T? Delta T is, so 80 minus 10. Final minus initial. So which is 70. So now you can solve the question for the X value. See, whatever the X you get, that is the water, the steam which is converted to water. But they are asking what is the final water present. So you have to add this 20 plus whatever the value that X you get here. Okay now. So whatever the X that you get here, and you should add it to the 20. That will be the final amount of water. So try that calculations on your own. So do those calculations, guys. First. So do the calculations. Here X into 540 X plus, so this will become 20X is equals to, so this is 1400. So I can write this one as 560X is equals to 1400. So here 0, 0 cancel. So the X will become 140 by 56. So which is nothing but, so 56 one time, 56. So 2 times. So 2 is 100, 112. So 3 times it will not go. So 112. So that means something around 38. So not 28 will be left. So 28 0. So 280 means something around. So I can take some 5 times. So somewhere around 2.5 grams. So this we get. And then so 20 grams. So the steam has converted to 2.5 grams of water. So 20 grams original cold water plus this is the steam which is converted to water, 2.5 grams. So total it will be 22.5 grams of water present. Clear? Understood everyone? Sure. So this question you guys can take it as a homework. So actually I'm not feeling well, so I'm going to wind up the session here. So this question take it as a homework again. So this question also you take it as a homework. So simple concepts only, you guys can try it on your own. So from heating curves and the heat transfer we'll start in the next session. So till then keep studying. All the very best guys. Bye.